Hi guys, welcome back. So in today's tutorial we're going to be looking at creating this particles effect here. You can see when we move our mouse, the particles, they move away from the actual mouse, and we have this easing animation, so the particles return to their initial position. We're using the math wrap, we're using many math functions in this, so it is quite math intensive, but I think it's a really cool effect. And you can see we have different sized particles here using like a randomized math function. And yeah, I think it's a really nice like a hero section kind of animation, which I've seen on a awards website recently, which I'll link in the description of this video. But yeah, hope you enjoy guys, and let's get going. Thanks. Okay guys, so as always, to get started, you can see I've just got an index.html, style.css and an app.js. We'll just get our HTML up and running first. There's not much HTML for this project, so I've just emitted some boilerplate code here. And then what we want to do is we just want to link to the style.css in the header. So we just say link, and we'll just say style.css, and then in the body we'll link to our script, JavaScript file with a script source tag, and we just point that to our app.js file. Now, coming into our actual body, the first thing we want to do is I just want to add that canvas, which we're going to be applying the pixels or animating the pixels with. So we can just say canvas element here. I'm just going to give this an ID as well of canvas, like so. Okay, and then underneath that we'll just have a header, and then in here we'll just say h1. I'm just going to use my name for now. And then underneath this we'll just have a hero div, div of a class of hero, and then we can just say in here h1 and put whatever you want. But I'm just going to put some text in here. This will be like a hero section, so I'll just say web designer. I'll do a break, and then we'll just say and developer, like so. Okay, and then that is it for our HTML. So let's just open this with live server just so we can see our edits as we go along, and there you go. Okay, so now the next thing I want to do here is let's go to our style.css next. And yeah, there's not too much style in here. All the magic happens with JavaScript for this tutorial. So the first one I want to do in our style.css is just do the all selector. We'll say margin 0, padding 0, and box sizing of border box. And this will just reset all of the default margins and padding, so there's no kind of white space you can see there. And then I'm also going to give this a min width of 0. It's not really important for this tutorial, but this is something I'm using now. I saw in a Twitter post that this is a very it's good to do this just to overwrite some weird behavior with CSS. Okay, and then next I want to do is just say font family, and we'll just say sans serif for now. Give it that nice sans serif font, and then we'll just do a text transform of uppercase just to capitalize all of our text, like so. I'll give it a font weight of 400. Let's make it a bit lighter, and then we can also just say color of white. I want all of our text to be white for this tutorial. And then the next one I want to do is we can just say HTML and body, give us a background color of black, like so. Okay, now the next thing I want to do here is we just want to target our canvas next. So I do the canvas hashtag because we use the ID selector. And here we're just going to say position absolute. Actually, what we can do we'll just take that off because we're only using one canvas element for this project, so we can just target that canvas directly with CSS. Say position absolute. I'll say top 0, left 0, width of 100%, and I want to give it a height of 100 small viewport heights, so SVH. And this will just I always use this now just to account for mobile devices. I know with my iOS mobile device, you get some weird behavior when you scroll the page. The viewport changes size. So this is what I use just to make it apply the height to be the smallest viewport height when the address bar is in the viewport of an iOS mobile device. Okay. So if I just do a background color of red for now, just to make sure that's taken up all of our screen, it should have done. And there you go, that's looking good. Okay, and then what I want to do next is we'll just target our header section. So we'll say header, and we'll say position relative, and we'll just say a height of 60 pixels, and then we'll also just say a width of 100%, like so, and then we'll say display flex, because I'm only using display flex because I want to center this text here, and then we can just say align items to the center. So we'll just say align items center, and you should see that that's vertically aligns that text to the center. And then we can just say padding left of 2 rem, like so, just give it a bit of white space to the left as well. Okay, and then what I want to do next is just target that H1. So I'll just say header H1, and I just want to give this a font size of 1 rem, just make it a bit smaller. Okay, so now underneath that, next one I want to do is just grab my hero section. So say dot hero. We'll just say position relative again. And I want to give this a height, and we're going to use the CSS calc function here. I'll just say calc, and I want to use 100 SVH, and I want to subtract 60 pixels just to account for that header. Okay, so now you'll see if we change the background color to blue, you can see we don't get that it takes up the rest of the viewport, that header section. And then what I can do next is just target the H1 in there. So say dot hero H1, we'll say position absolute, and I'll just say bottom 2 rem, and we'll just say a left of 2 rem as well, just to align it with our header text. Okay, so we'll just go with that for now, and that is it for our style.css. Okay, so now let's get the actual canvas going, that animation. Let's get the particles loaded on the screen. So let's go to our JavaScript file next. Okay, and then so what we want to do, the first thing is just get some selectors going. So let's just first target our canvas. So say const canvas equals document dot query selector, and we can just say the canvas in there like so. Next, we want to do is grab the context that we're going to be using to draw onto this canvas. So if I just console.log canvas, just to make sure that it has grabbed it, you can see, yeah, we have our canvas logged there. That's great, and it takes up the full viewport now, because in our CSS we have made it, well, we've given it a height of the same, well, the height of the viewport basically, and a width of 100%. So now let's get the context next. So we can say const ctx for context equals canvas dot get context. Context, and we're going to go for a 2D drawing context. Okay, because it's only going to be a 2D animation. We're not going to be using WebGL or anything like that. Okay, and then next what I want to do here is just say canvas dot width. And what we need to do here is we just need to account for the different types of screens that this canvas will be animating on. Obviously, we have like retina displays on, you know, most Apple products, and then we also have like, you know, basic standard monitors which have a lower pixel ratio. So what we're going to say here is canvas width equals window dot inner width times the window dot device pixel ratio. Okay, and then we'll do the same thing for the height. Just say canvas dot height. Okay, and then we can just say leave that, and then we just say inner height. Okay, so now what we need to do, so you'll notice I'm on a standard display here. This isn't like a retina display or anything. So if I just do window dot device pixel ratio, you'll see, well, it's not like a, it's around 1 basically. Okay, so that's what we're going to be, that's what the device pixel ratio will be, and that will make the animation look great on this display. If you look on a retina display, the device pixel ratio is usually around 2, so that's what we're doing here. Now what this will do, this will we need to just align the canvas size with the viewport again. So what we need to do here is we just say canvas dot style dot width, and here we're just going to use some template literals, so backticks there, and we'll just say window dot inner width should be inner width, and we use px for pixels, and then we'll just do the same for the height. Style.height equals window.innerHeight, and this sets up our canvas to look good on all kind of displays. Okay, so now what we want to do now is we want to create two classes, one class called effect and one class called particle. So let's do the particle first. We'll say class particle, and this will be used to spin up instances of all of the different particles on our animation. So class particle, and that will take in a constructor, and then we also just want the actual main effect, class effect. Okay, constructor. Now, before we proceed with this, I just want to give a shout out to Frank's Laboratory, his YouTube channel, because and I'll point a link to the description where I learned this particle technique. It's a really good video, and it probably would explain it better than me. It's a bit of maths involved in this animation, so yeah, see the description for Frank's video if you want to look into this further, this effect. But so let's just get the for instance of the class up and running first. So we just say constructor, and here for the class effect, this is going to take in three parameters. Okay, so it's going to take in the width of the canvas, it's going to take in the height of the canvas, and it's going to take in the context, which is what we created at the top of our screen here, this context here to draw to the canvas. Okay, so in here we can just say this dot width equals the width, and then we want to say this dot height equals the height that we pass in, and then this dot ctx equals the context that we pass in here as well. Okay, and then for this effect we're going to have an array of particles. Okay, so we'll have loads of particles on our screen, and this array will be used so that our effect can loop through each particle and animate as and when required. So we can say here this dot particles array equals an empty array. Okay, and then what we can do next is we're just going to say this dot mouse. That's going to equal an object, and it's going to have three parameters in this object. So we're going, first thing is the radius, and that will be 3000, so quite a large number. We're going to have the x position, and we'll leave that at 0 when we first load the page, and the y position. So this will be the x and y position of our mouse. So for example, top left it will be 0, 0, and then it will increase as you go around. So let me just show you now. So for example, if we say window.add event listener, we'll listen up for a mouse move event, and then we pass that event into a arrow function here, and what we can say is console.log this.mouse.x and this.mouse.y. So now if I just say, we'll come to the bottom here, and I will say let effect equal new, we'll say new effect, like so, and that will take in our canvas width first. So we can say canvas dot width, we'll say canvas dot height for the height parameter, and then we need to throw in the context as well, so I'll just say ctx here. Okay, so now what that will do, that will spin up a new instance of this effect class, and in the constructor we run this event listener, this mouse move event, so now we should be getting the coordinates of our mouse logged in the console of the browser. We come to the console here. Okay, so what we need to do is say this dot mouse dot x equals e dot client x, and this dot mouse dot y equals e dot client y. So now you'll see, now we get the actual coordinates. So the top left it will be close to 0, 0, and then you can see, we get the x and y coordinates of our mouse on the viewport there. Okay, so that's looking good. Now what I want to do in this mouse move is I'm actually just going to say we're going to need to times this by the device pixel ratio as well. So say window.device pixel ratio, just to account for this setting up here, just so it aligns with our device pixel ratio. And then for the y position, I'm actually going to change the client y, and I want to change this to page y. and I want to just say, yeah, times device window dot device pixel ratio. And the reason for that we're using page wire here is because we want the animation to still we want our mouse to still cause animate. We want it to animate at our mouse position regardless of how far we've scrolled on the screen. If you're using the client to do that, the client X, it won't be aligned with the actual canvas, the mouse over the canvas. So that's why we're using that page wire variable there. Okay, so that's pretty much it there. We can just delete that console log. We don't need that because that takes up performance. Okay, and then the next thing I want to do as well is just in the constructor, we can just say window dot add event listener, and we want to listen up for a resize event. Okay, and then what this will do, we'll just say here, canvas. I'll take this again. I'll just copy this up here. We can copy these four actually. So I'll put this here like so. And this is just so our canvas, you know, the dimensions change along with our resize of the window. And then also I just want to say, we want to change this dot width as well. So we can say this dot width equals canvas dot width. And this dot height equals the canvas dot height. We're going to be referencing these variables within our animation function. And then I also just want to delete, when we resize, I want to delete all of our particles. So we'll say this .particles array, we'll reset it to a blank array. And then we're going to run an init method just to, you know, reinstantiate these particles. Okay, I don't know why it's doing that. Let's just create a let's create a function called, a method called init. So if we come underneath outside of the constructor here, I'm going to do a method called init. Okay, and now what we can say is this dot init for initialize. And then let's actually run that as well in our constructor. So I'll come out of this event listener and we can just say this dot init. So this is when the program first begins, when the page loads. So in our init function, we're just going to do a for loop. Okay, so we can. What else I need to do here actually is I didn't set a gap. So let's just do that now. So underneath our particles array, we'll just say this dot gap. And we'll just put that to 20 for now. And this is going to be the gap in pixels between each of our particles. There'll be a 20 pixel gap between each particle on the canvas. Okay, so now what we can do with this gap variable is we can do a for loop in our init function. So we can say for, we're going to do a nested for loop here. We'll say let x for the x-axis. So we're going to go across the canvas here. And then we're going to say whilst x is less than this dot width, so the canvas width, then we'll say x plus equals this dot gap. Okay, and then we're going to do the same thing. So for each row of particles, we need columns as well. So let's just do that now. So we'll just say for let y for the y-axis equals 0, whilst y is less than this dot height this time, then we can say y plus equals this dot gap. And then what we can next say is we want to push a new particle instance to our particles array within our effect class. We can say this dot particles array dot push new particle. Okay, and then what we need to throw in here for this particle, this is going to take in three initial parameters in the constructor. Okay, so that will be the x position of the particle, the y position of the particle, as well as the actual effect, the instance of the effect, so the whole effect that we have down here. So in our new particle here, we can just say x, because remember we're looping through, so we have the x variable, and then for the y, we can just chuck in the y. And then for the effect, we want to throw in this entire effect here so it can reference, you know, the actual context. So we can just say here, this. Okay, and this will, you know, add this whole instance of the effect, and allow this to be fed into the particle instance. Okay, so now that we've done that, the next thing I want to do here, so we have our init method. Let's have a look. So we've got our resize, we have our init, and let's just do some particle parameters now. So in our particle class, in the constructor, we can say this dot origin x equals x. Okay, we need the origin position because when we move our mouse, we'll be throwing the particles all over the place, and we need them to return to that original initial x position. So that's why we're storing this here. Do the same thing for the y. So we say this dot origin y equals y, and this dot effect equals effect, just so we can reference the actual parent effect. Okay, and then what else I want to say next is we can just say this dot x as well equals x, and it's best to actually just chuck this in a math.floor just for performance reasons. It's always better to deal with like whole numbers as opposed to like decimals, that kind of thing. So that's what we're using there, just math.floor. Do the same thing for the y variable as well. So this dot y equals math.floor y. Okay, and next thing we want to do here is get the context, just so we know, we can use that context to draw the particles to the canvas. So we can say this dot ctx for context equals, and remember we have the context in our effect class as this dot context. What we can do here is say this dot effect dot ctx. Okay, so now we can reference that context that we pass into the parent effect class here. And then I just want to change the fill style of this context to be white, as we're using the black background. So I just say this dot ctx dot fill style equals, and we'll just say white in as a string. And then we're going to have a vx. This is for velocity, and that's going to be initially 0. And we'll be using this velocity for the animation as well. So that's for the velocity on the x-axis. We'll have the velocity on the y-axis, so vy. And then we want a this dot ease, and this will be used to determine how quickly our particles return to their original position, their origin x or origin y. So we can just set that to this 0.2, and we'll adjust these settings later just so you can see how this dot ease affects the animation. And we also need a friction as well. So say this dot friction equals, and we'll say 0.95. Next thing we want to do is just say this dot dx. So this will be used to show the direction on the x-axis. So we'll say this equals 0 for now, and this dot dy will equal 0. And then this dot distance. So this will be used to measure the distance between the mouse and the actual particle. Okay, we need to reference that. So we can just initially set that as 0 as well. And then we want this dot false to equal 0. Again, we'll be applying this false with some equations below. And then we also want to say this dot angle equals 0. And we'll be using this dot angle to say, so when we have a mouse, the particles will form a circle around the mouse, and this angle will be used to determine which direction the particles will be moved to the circumference of the mouse. Okay, and so we have this dot angle, and then finally we'll just do this dot size equals, we'll say 2 for now. We'll randomize this later just so you can see that effect. And then we can say we're going to have a method called this.draw, which we'll create now. Okay, so if we come out of our constructor, we'll do that draw method. And then when we want to say here is this.ctx.begin path. So that's a function, so this will tell the context to begin to begin a drawing of a particle to the canvas. And then we can say this.ctx.fill rect for fill rectangle, and then we want to use this dot x that we pass in, so this here, this dot x, and then this dot y, and then for the width we can just say this dot size, and we want it just to be the same size all around, so we can say for the height this dot size as well, which we set to 2 in the constructor here. Okay, and now you can see our particles have been drawn. Okay, and then when we resize, you'll see the gap remains constant. Okay, so that we've set a constant gap to 20. We can obviously change that to say, you know, this dot or window. We'll say 20 for now, but yeah, in our here we could just say, for example, if you wanted to adjust it to the viewport, we can say where do we want to do this? Yeah, we'll say this dot gap equals window dot inner width divided by 100. So now when we resize, you can see here the particles adjust with the viewport, but I want to keep our particles constant for now, so I'll just leave that and we'll just keep the gap at 20 regardless of the actual viewport size. Okay, so now that we've done that, I want to just apply an update function in our particles class here. So we'll just say update, and this is where the magic happens, the animation happens. So what we can say here is first we want to grab our dx for the direction x, and what we're going to use here is we're going to say this dot effect dot mouse dot x minus this dot x. So we're using our mouse move and then we're subtracting the distance. So we're getting the distance from our mouse x minus the actual x position of the particle. Okay, and then we can say this dot distance y equals this dot effect dot mouse dot y minus this dot y. And then from this, now we can work out the distance. Okay, so then we can just say this dot distance equals this dot dx times this dot dx plus this dot dy times this dot dy. Okay, so this is like kind of a Pythagoras theorem equation here. I'm not brilliant at maths, but this is how you do it. So you it's basically the x position squared plus the y position squared, and that will give you the distance diagonally from the mouse to the particle. Okay, so now what we want to do now is change this dot false as well, which we created up here, this dot false in the constructor, and we're going to say equals, and we're going to use a minus sign here, and then we want to take this dot mouse dot radius, which we applied down here, 3000, and then we want to divide that by this dot distance that we created here. I'm just going to times that by 8 just to give it, you know, a lot of it'll make the false appear larger, and the false will be used to determine, you know, how violent the animation is. Okay, and then the next thing I want to do here is I'm going to say if this dot distance is less than this dot effect dot mouse dot radius, that means, you know, the particles are near our actual mouse position. Then what we want to do here is we want to create an angle. So say this dot angle equals, and we're going to use the math dot atan2 function, and this takes in a y and an x. So here we can just say this dot distance y and this dot distance x, so dx. Okay, and that will give us an angle. And then what we can say here is underneath this, we'll say this dot velocity x, so vx equals, plus equals, and then we can use that false that we created up here, so this dot false, and then we can times that by math dot the cosine function, so math dot cos, and then we can use this dot angle, and then we can say this dot vy plus equals this dot false, and here we can use the it's basically the opposite to the cosine, which is the sine function, and then we're just passing this dot angle again, which should give us a nice circumference around our mouse. Okay, and then coming out of this if, we can just say this dot x plus equals, do some brackets here or parentheses, and then we'll just say this dot vx times equals this dot friction. Okay, and then out of that parentheses we'll just say plus this dot origin x minus this dot x, and then we'll times that by the whole thing, come out by this dot e's, and this will make our particles return to their initial position. We're just adjusting the x position, and as for each animation frame we gradually return it to this dot the original position using the friction and the easing numbers that we created. Okay, it wants to do the same thing for the y, so I'll just copy this down, and here we can just say this dot y, change that x to y, and then obviously vy, and then this dot origin y minus this dot y as well. Okay, and then after that we can then do this dot draw, and that will make our particles. And what we do need to do in this dot draw as well is just say no, that's fine. Okay, and then we can just say this dot draw. Okay, so now what we need to do is I'm actually just going to do an update function in our effects class as well. So we'll come out of the underneath the unit, we'll just say update, and here what we need to do is just say this dot ctx dot clear rect. Okay, and this will just clear the whole canvas in order for this animation to work. So we can just say 0, 0 to clear it from the top left. Once we take in, we'll just say this dot width and this dot height. Okay, and then what we want to do next is loop through each of our particles array and run the update function within that particles array. Okay, so now we can just say this dot particles array. Actually, I want to do a for loop. I won't do a for each because I think I've heard for loops are better for performance. So I'll just say for let I equal 0 whilst I is less than this dot particles array dot length. We'll say I plus plus, and then here we can just say this dot particles array I, so the iteration that we're on, and then we can just run the update function on that. Now so we've got in it. Now what we can do, so I'm going to come underneath here. You'll see nothing's happening now because we're not actually running this function, the update function here. So we can actually just do that in an animation frame outside of everything. So I'm going to do a function called animate here. And here we're just going to say effect dot update, like so. Okay, and then we can just say request animation frame. Animate, so this will call this function over and over again, 60 frames per second. If I run animate outside here, and let's see what's going on. You can see I've got an error. Can't read the radius. So if we go to 41, what that error is, and that should be because we're in the particle, this should be this dot effect dot mouse dot radius. So 41, this dot effect, and now you can see we have our animation working, and our particles now move away from the mouse in a circular manner. Let's just I just want to try something actually. If we just don't clear the rect, so what would happen? This is why we clear the rectangle, or the canvas rather. You can see we get this really weird effect come on. I mean, it's quite cool actually. You might want to keep it, but it just basically means when the particles move, the canvas, if you don't clear it, they stay there permanently, the paths of the particles. So that's why we use that clear rect function. And then you can also adjust the gap as well. So for example, if you use 10 pixels, I think the smaller the gap, the more particles. So you may run into some performance issues if you have, obviously, the wide screen, you get a lot of particles there, but it seems to work fine. And then you can also adjust this effect by what I would like to do is just say adjust the size. So what we can do here, we'll say this.size equals math.random times 5, and I want to just math.floor that as well, just so it's a whole number. And then you can see we get, you know, different shape, different sizes for our particles. I think that looks quite cool as well. Maybe 5's a bit too big. Let's just go, well, let's just change the gap actually to, let's go to 20 again. And yeah, you know, I think it's a pretty cool effect. It's nice when you have different size particles. And yeah, let's just change the header style to be black. I'll just say background of black here. And there you go. So yeah, I hope you enjoyed that, guys. I think it's a really cool effect. Yeah, thanks again to Frank's Laboratory for his tutorial. As I said in the beginning, I've linked to his tutorial in the description of this video, so check that out. He does this effect with actual images as well, which is really cool. But yeah, I hope you enjoyed, and I'll see you in the next video. Thanks, guys.